Everyone, I'm Wendy. Today's topic is T distribution. I'm going to finalize chapter 4 estimation today. Let's see what the T distribution is. Okay, here is definition of T distribution. It is a little complicated, but not that difficult. Okay, we get confidence interval for mu at 1 minus alpha 100% confidence level. Okay, what was it? Let's see again the result. We got this confidence interval for mu, right? But we cannot use this interval, because we do not know sigma. Sigma is what? Population standard deviation, uh, right? So we cannot use this what range in practice. And just see these steps from this graph, okay, from here, and we just change the part, center part especially, in order to remain mu only at the center. It is equation, but you may understand this kind of steps, I expect. Okay, let's see again here. Okay, we do not know sigma, therefore we must replace sigma with S. What is S? S is the best estimator of sigma obtained from the sample. Best estimator. S is best estimator of sigma. So replacing estimator S for sigma here replace S here, it becomes x bar minus mu over S over square root of n, right? Then it is very complicated. It has very complicated distribution because x bar and S are random variables. Okay, both of them are random variables. So this one, new one, follows different probability distribution, not standard normal distribution. So let t equal to this one. Okay, then t new random variable t follows a t distribution with degrees of freedom n minus 1. S has degrees of freedom n minus 1, right? So t distribution has degrees of freedom. You understand? Okay, there exists, of course, probability distribution function of t. Very complicated. Actually, I don't remember. I don't have to memorize this complicated equation. So you don't have to do it. You don't have to know what f of t. Okay? T distribution is a symmetric distribution with mean 0 here, 0. Okay? And lower peak compared to the normal distribution. This is normal, standard normal. And the t distribution is like this. The top is lower than standard normal, like this. But it has what? T, G. It has degrees of freedom. As degrees of freedom increase, it approaches to the normal distribution. The peak gets higher and higher, finally normal, when sample size increases. Okay, that is properties of t distribution. Okay, the confidence interval for mu at confidence level 1 minus alpha 100% was obtained as like this. But in practice, we cannot use this one because we do not know sigma. So we replace S here in place of a sigma S, then it's going to be change T. The new random variable T. As I told you, just before. So remember, this graph is t, okay, 0. Then now 1 minus alpha in center, and alpha over 2 at each tail. Then center is 1 minus alpha, right? Then t is what? T is here, x bar minus mu divided by s over square root n. Oh, here, like this. So this value is t alpha over 2. Then it is symmetry minus this value will be t alpha over 2 minus t alpha over 2. This one t alpha over 2. So we got this relationship, okay, relation. From this relation, we replace t here, right? Then we just take several steps. Then finally, we get, as before, finally, we got this equation. So what is this equation implies? Mu is greater than x bar minus t alpha over 2 times s over square root n plus t alpha over 2 s over square root n. In that range, the probability mu lies in the range is 1 minus alpha. It is what? Confidence level 1 minus alpha. At confidence level 1 minus alpha, the confidence interval is this, as before. So we can use this confidence interval for mu, okay, in practice. In practice means when you have sample values and you can calculate x bar, you can calculate s, and the n is what? Number of sample, right? Samples. T value is like what? G value, but not G. Here, T. So you can, these values can be found in statistics textbook appendix. Okay, so you can calculate everything here. So here, so you get final confidence interval for mu. Okay, this one is for population mean, but population variance or population proportion or other parameters, the logic is just the same. Okay, just a little different part, but the essential of the logic is just the same. So if you understand this chapter, this especially confidence interval estimation, then you are very much prepared to go further. Further means test the hypothesis and the statistical analysis method. Okay, this is it. Thank you. Bye.